All right, guys, we're going to go over how this circuit works. So let me draw it out for us. We're going to have, in this scenario, I'm going to draw what we have right now wired up. I have a 220 ohm resistor. That's the symbol for ohms right there. Let's move this over. I have a 220 ohm resistor. And then we go, let's bring him over, into this LED. And then I go back to ground or back to negative. So this right here, wow, I wrote that odd, didn't I? There's an LED. So what goes on in this circuit, the reason we need this resistor is, let me draw it in another color. We will start out with 5 volts roughly coming from my 5-volt pin on this Arduino board. When it goes through this resistor, that 5 volts is going to get eaten up a bit, and we may step down to 2.1, something of the sort. We can actually do the math and find that out. When we get to the LED, we put 2.1 volts there instead of 5 volts, and that way we don't put too much power to this light. And this LED consumes all of that voltage and turns it into light. So when we get to the other side of it, there is 0 volts. All of this is respective to ground. So we need to make sure all of that voltage is consumed before we get to the ground pin, or we're going to have a direct short. If I had something like this, that would be a direct short to ground. Before all that voltage is consumed, we don't want anything like that. So let's just get that out of there. Now, I'm going to put a switch in this scenario. So we're going to look now, and I'll show us the meter readings on all of this too. Same deal with this resistor. And now let me put in a switch. And this is a lot like a light switch. So let's draw him like, I'm used to drawing high voltage electrical drawings, so forgive me. But if I push down on that switch, that will make that little bridge, and it'll put power to this light that I'm about to draw. We'll give it a little more right there. I'm drawing that in red because it's still hot, still 5 volts. We go into this light right there. And now we go to ground. This light won't be lit up yet. We have to close that switch to do so. So let's draw that. I've got positive going through that resistor and doing this to make it a little clearer. Bam! We push that switch down, and when that happens, that power goes over to my LED and turns all that voltage into nice, pretty light. Same deal what's going on here. My voltage is getting eaten up a bit by this resistor. So let's say I've got 5 volts there, 2.1 coming out here. When this switch is open, what we're reading on our meter is the difference between 2 points. So when I'm saying 5 volts, there's 5 volts difference between this point and ground. Ground is going to be 0 volts, like I mentioned up here. So this right here, when I have 2.1, when I say difference, that means minus. If I'm checking across an open switch, there's 0 volts there. I'm going to read the voltage applied to that switch, 2.1 minus 0, 0. Whereas when I come into this scenario, we had 5, that stepped down to 2.1. I would have 2.1 here. If I put my meter leads, red and black, across, let's just grab my meter leads, right here, I would read 0 volts because 2.1 minus 2.1 equals 0 volts. And let's just draw that out. 0 volts. That's a meter reading right there, right? Still same deal. This 2.1 volts is all getting turned into light. And now I have, let me erase that to clear it up, 0 volts right here respective to ground. Let's take a look at what all that means with a multimeter. Let's grab this, set my settings. Let's grab me one more wire so we can see these readings. Okay, I'm going to check this red wire here, and this is where my power comes from. It's my 5-volt pin to this black wire here, and that's my ground. And my meter tells me about 4.6 volts. I'm not holding it perfectly steady, so that's why it was jumping around, but about 4.6. So fairly close to my 5 volts there. When we go through this resistor, I'll still have 5 volts on the front side of this resistor to ground. Let's use you out of the way now. And let's just put him here so I can touch that a little bit. Front side of the resistor to ground. Sorry guys. Front side of the resistor to ground. 4.7, still same amount of voltage. Now when I check the other side of that resistor, 2.1. Pretty good. We'll have 2.1 going all the way to the LED. And then if I were to check the back side of the LED to ground, all of that voltage has been consumed, so I'm going to read 0 volts. 0 volts. Boom. All of that going through this. So now when I move this wire to include this switch in my circuit, my light's not going to light up because that switch is open, it's not passing power over there. When I press that switch down, bam, that's when we get the light to light up. If I checked the voltage across this right now, we would see, let's put a wire in here and get a good test. Right there. I'm going to read my 4.7 volts. Oh, let's test here. Let's test there. Or 3.3. For whatever reason, I'm losing some voltage through there. But if I were to close this switch, this is going to read 0. Bam. 0 volts. Because there's no difference now between the front and the back side of this switch. No difference. Awesome. Now we know how and why this circuit works.